Okay, good morning students. Today we will work out some more problems in the solution of ordinary differentiation by using Laplace transform technique. The problem says that y double dash plus y dash plus 9y is equal to 0. This is an ordinary differentiation. The basic conditions are y0 is equal to 0.16 and y dash 0 is equal to 0. This is the initial conditions. We can solve the ordinary differentiation and find the value of y. For that, just similar to previous case, y double dash plus y dash plus 9y is equal to 0. This is the ordinary differentiation given. We take the Laplace transform L of y double dash plus L of y dash plus 9 into L of y is equal to 0. Taking Laplace transform on both sides. Then applying the formula L of y double dash. The formula is square y bar minus s y0 minus y dash 0. S square y bar minus s y0 minus y dash 0 plus L of y dash s into y bar minus y0 plus 9 into L of y, 9 into y bar is equal to 0. We applying the basic conditions. Therefore, s square y bar minus y0 is equal to 0.16. Upon s into 0.16. Y dash 0 is equal to 0. Then plus s into y bar minus y0 is equal to 0.16 plus 9 into y bar is equal to 0. Then s square plus s plus 9 into y bar is equal to 0.16s plus 0.16. That is 0.16 taken outside s plus 1. Therefore, here we take y bar terms in left hand side and the other terms in the right hand side. Therefore, s square plus s plus 9 into y bar is equal to 0.16 into s plus 0.16. When we take 0.16 outside, 0.16 into s plus 1. Therefore, y bar is equal to 0.16 into s plus 1 divided by s square plus s plus 9. S square plus s plus 9. This is equal to 0.16 into s plus 1 can be taken as s plus 1 by 2 plus 1 by 2. S plus 1 can be taken as s plus 1 by 2 plus 1 by 2 and denominator s square plus s plus 9. S plus 1 by 2 the whole square plus 9 minus 1 by 4. That is 35 by 4. Root of 35 by 2 the whole square. You just listen here. Here 0.16 into s plus 1. This s plus 1 can be split into s plus 1 by 2 plus 1 by 2. And denominator s square plus s plus 9. Denominator s square plus s plus 9 can be taken as s plus 1 by 2 the whole square. When we take s plus 1 by 2, when we expand this term s square plus s plus 1 by 4. That 1 by 4 is subtracted from 9. 9 minus 1 by 4 is equal to 35 by 4. This 35 by 4 can be taken as root 35 by 2 the whole square. Therefore, this can be written as 0.16 into s plus 1 by 2 s plus 1 by 2 the whole square plus root 35 by 2 plus 0.08. When we multiply 0.16 into 1 by 2, the result will be 0.08 divided by s plus 1 by 2 the whole square plus root 35 by 2 the whole square. This is the standard form of the Laplace transform. To convert standard form of the Laplace transform, we taken as s plus 1 as s plus 1 by 2 plus 1 by 2 and denominator s square plus s can be taken as s plus 1 by 2 the whole square. Then we can easily apply the formula. Therefore, y is equal to L inverse 0.16 L inverse s plus 1 by 2 by s plus 1 by 2 the whole square plus root 35 by 2 plus 0.08 L inverse 1 by S plus 1 by 2 the whole square plus root 35 by 2 the whole square. It's split into. Then this is the standard form. By applying the standard form, the result will be 0.16 into, by using first shifting property, we can return as e raised to minus 1 by 2t. E raised to minus 1 by 2t cos root 35 by 2t. Cos root 35 by 2. Root 35 by 2 plus the second result, the standard result of the sin 80. By using the first shifting property, 0.08 into 1 by root 35 by 2 e raised to minus 1 by 2t sin root 35 by 2t. This is the result. Therefore, we solve the ordinary differentiation by using Laplace transform technique. We get the value of y is equal to 0.16. The value of y is equal to 0.16 into e raised to minus 1 by 2t cos root 35 by 2t plus 0.08 e raised to minus 1 by 2t root 35 by 2 into sin root 35 by 2. This is the result of the given problem. Y double dash plus y dash plus 9y equal to 0. The basic conditions are y0 equal to 0.16 and y dash 0 is equal to 0. We solve this differentiation and finally we reach the point y. We get the value of y that is equal to 0.16 into e raised to minus 1 by 2t cos root 35 by 2t plus 0.08 into 1 by root 35 by 2 e raised to minus 1 by 2t sin root 35 by 2t. Here we please listen the point. Here the s plus 1. There is a s plus 1 here. This s plus 1 we shifted as s plus 1 by 2. After converting s plus 1 by 2 we can apply the standard result. Therefore, s plus 1 can be taken as s plus 1 by 2 plus 1 by 2 and the denominator s square plus s can be taken as s plus 1 by 2 the whole square. When we take s square plus s as s plus 1 by 2 the whole square, one term remaining 1 by 4, that 1 by 4 is subtracted from 9. Therefore, 9 minus 1 by 4 that is equal to 35 by 4. This 35 by 4 can be taken as root 35 by 2. Therefore, root 35 by 2 the whole square. Finally, we arrive at the result. This is the procedure for solving this ordinary differentiation. Then we can do one more problem. We can do one more problem. Solve y triple dash minus 3y double dash plus 3y dash minus y is equal to t square into e raised to t. The conditions are y0 is equal to 1, y dash 0 is equal to 0, y double dash 0 is equal to minus 2. This is the conditions. We can solve this problem by using Laplace transform technique. The question is y triple dash minus 3y double dash plus 3y dash minus y is equal to t square e raised to t. The conditions are y0 is equal to 1, y dash 0 is equal to 0, y double dash 0 is equal to minus 2. Just similar to previous case, first we take Laplace transform. Therefore, L of y triple dash minus 3 into L of y double dash, 3 into L of y double dash plus 3 into L of y dash minus L of y is equal to L of t square e raised to t. Here right answer is not equal to 0. Instead of not 0, here the function is t square e raised to t. Then we apply the result. L of y triple dash. We know the result is s cube y bar minus s square y0. S cube y bar minus s square y0 minus s y dash 0 minus y double dash 0. Then put in the brackets. You put in the bracket. Because this represents L of y triple dash. Therefore, L of y triple dash can be taken as s cube y bar minus s square y 0 minus s y dash 0 minus y double dash 0 minus 3 into L of y double dash s square y bar minus s y 0 minus y dash 0. This is for L of y double dash plus 3 into L of y dash s into y bar minus y0 minus y bar is equal to right hand side is equal to L of t square e raised to t. We know the formula. L of t raised to n is equal to n factorial by s raised to n plus 1. Therefore, using first shifting property, e raised to at t raised to n is equal to n factorial by s minus a whole raised to n plus 1. By using this first shifting property, L of t square e raised to t is equal to 2 divided by 2 factorial, 2 divided by s minus 1 the whole cube, 2 by s minus 1 the whole cube. Oh, first we take the Laplace transform on both sides. We take each function y triple dash, y double dash, y dash, y. We take the Laplace transform and right hand side by using first shifting property and the result of L of t raised to n 2 by s minus 1 whole cube. Then next step is we applying the conditions. We have to apply the conditions. The conditions are s cube y bar minus s square into y0. y0 is equal to 1 minus s into y dash 0 is equal to 0. Minus y double dot 0 that is equal to applying the conditions minus 3 into s square y bar minus s y0 is equal to 1 s into y0 s into 1 y dot 0 0 plus 3 into s into y bar minus y0 is equal to 1 minus y bar is equal to 2 by s minus 1 the whole cube. After taking the Laplace transform on both sides, we applying the given conditions. The given conditions are y0 is equal to 1 s square into y0 s square into 1 minus s into y dot 0 is equal to 0 s into 0 y double dot 0 minus 2, therefore minus of minus 2 minus 3 into s square y bar minus s into 1 minus y dot 0 0 plus 3 into s into y bar y0 is equal to 1 minus y bar is equal to 2 by s minus 1 whole cube. Then releasing the bracket. When we are releasing the bracket, s cube y bar minus s square plus 2 minus 3 s square y bar plus 3s minus 3 into minus s. Therefore, plus 3s plus 3 into s y bar minus 3 minus y bar is equal to 2 by s minus 1 the whole cube. Then we take the y bar terms. Therefore, s cube first term minus 3s square the second term, then plus 3s third term, then minus 1 into y bar term taken outside. That is equal to 2 by s minus 1 whole cube, then minus s square. Then minus s square we can take as plus s square, then minus 3s, then plus 2 minus 3 minus 1 that will become plus 1. Therefore, we take y bar terms in one side s cube minus 3s square plus 3s minus 1 into y bar. Right hand side 2 by s minus 1 whole cube, then plus s square minus plus 3s becomes minus 3s plus 2 and minus 3, the minus 1 that is plus 1. That is, this s cube minus 3s square plus 3s minus 1. This is the expansion of the a minus b the whole cube. We know that a minus b the whole cube. A minus b the whole cube is equal to a cube minus 3s square b minus 3 plus 3ab square minus 1. This is the expansion of the a minus b the whole cube. Therefore, s cube minus 3s square plus 3s minus 1 into y bar can be taken as s minus 1 the whole cube into y bar is equal to 2 by s minus 1 the whole cube plus s square minus 3s plus 1. Therefore, y bar is equal to 2 by s minus 1 whole raised to 6 plus s square minus 3s plus 1 divided by s minus 1 into whole raised to 6. This can be taken as y bar is equal to 2 by s minus 1 whole raised to 6 plus s square minus 3s plus 1. S square minus 3s plus 1 can be taken as s square minus 2s plus 1 then minus s. This s square minus 3s plus 1 can be split into s square minus 2s plus 1 then one more minus s taken outside divided by s minus 1 whole raised to 6. That is y bar is equal to 2 by s minus 1 whole raised to 6 plus this can be written as s minus 1 whole square divided by s minus 1 whole raised to 6. Then minus one more minus s is here. This minus s can be taken as s minus 1 then plus 1 divided by s minus 1 whole raised to 6. Just arrangement of the terms. The first term is 2 by s minus 1 whole raised to 6 plus s minus 1. S square minus 2s plus 1 can be taken as s minus 1 whole square by s minus 1 whole raised to 6. The third term s can be taken as minus of s minus 1 plus 1. Therefore, simplifying 2 by s minus 1 whole raised to 6. This when cancelling this one we get s minus 1 whole square. Therefore, s minus 1 whole raised to 4. 6 into cancel 1 by s minus 1 whole raised to 4 minus s minus 1 by s minus 1 by s minus 1 whole raised to 5. Then minus 1 by s minus 1 whole raised to 6. Therefore, finally we reach the point 2 by s minus 1 whole raised to 6, 1 by s minus 1 there is a mistake here. Y bar is equal to 2 by s minus 1 whole raised to 6, 2 by s minus 1 whole cube, s square minus 2s plus, but here this is some mistake is here. Here s minus 1 whole cube, this is s minus 1 whole cube. I have taken it as s minus 1 whole raised to 6. Therefore, y bar is equal to 2 by s minus 1 whole raised to 6 plus s minus 1 whole square divided by s minus 1 whole cube minus s minus 1 plus 1 by s minus 1 whole cube. We just arranging the term. Therefore, 2 by s minus 1 whole raised to 6. Therefore, 2 by s minus 1 whole raised to 6 plus s minus 1 whole square 1 by s minus 1. Then s minus 1 by s minus 1, 1 by s minus 1 square minus 1 by s minus 1 cube. അപ്പോൾ 2 by s minus 1 whole raised to 6 plus 1 by s minus 1 minus 1 by s minus 1 whole square minus 1 by s minus 1 whole cube. This is known as L of y. Then we get to find the value of y. We take the inverse of the separate functions. We can take the inverse function. For that, then we apply the formula L inverse 1 by s minus a whole raised to n is equal to e raised to at into t raised to n minus 1 by n minus 1 factorial. We know the formula L inverse 1 by s minus a whole raised to n is equal to e raised to at into t raised to n minus 1 by n minus 1 factorial. By using this formula, y is equal to 2 by s minus 1 whole raised to 6, 2 into e raised to at, e raised to t into t raised to 5 divided by 5 factorial, first term. Then plus 1 by s minus 1. 1 by s minus 1 is equal to e raised to t minus 1 by s minus 1 whole square. 1 by s minus 1 whole square is equal to e raised to t into t divided by 1 factorial. Then add the e raised to t into 1 by s minus whole square, t square divided by 3 minus 1, 2 factorial. Therefore, the final result will be 2 into e raised to t into t raised to 5 by 5. Then second term e raised to t, third term e raised to t into t, and the third term e raised to t into t square by 2. Similarly, we can solve the ordinary differentiation. Here right hand side is t square into e raised to t. After taking Laplace transform on both sides, finally we reach the point y is equal to 2 into e raised to t into t raised to 5 by 5 factorial plus e raised to t minus e raised to t into t by factorial 1 factorial minus e raised to t into t square by 2 factorial. Here we just rearrange the term. Here rearrange the term. Here 2 by s minus 1 whole cube. This is s minus 1 whole cube, where we convert this into s minus 1 whole raised to 6. And the second term s square minus 3s plus 1 can be taken as s square minus 2s plus 1. Then minus s. Then we rearranging 2 by s minus 1 whole raised to 6 plus s minus 1 whole square by s minus 1 whole cube minus this s can be taken as s minus 1 plus 1. This s can be taken as s minus 1 plus 1. Adding and subtracting 1. Then 2 by s minus 1 whole raised to 6 plus 1 by s minus 1 minus 1 by s minus 1 whole square. S minus 1 by s minus whole cube, 1 by s minus 1 whole square minus 1 by s minus 1 whole cube. Then applying the formula, standard formula, L inverse 1 by s minus a whole raised to n is equal to e raised to at into t raised to n minus 1 by n minus 1 factorial by using first shifting property. By using that formula, we get 2 into e raised to t into t raised to 5 by 5 plus e raised to t minus e raised to t into t by 1 factorial minus e raised to t into t square by 2 factorial. This is the method to solve the given ordinary differentiation. Okay, thank you.